Namaste. All right. Hey guys, it's Mr. Golis here, and I wanted to talk to you guys about the concept of acceleration because it's kind of an important concept in physics. This is kind of a general video for all my classes, so I'll speak about it in a general way, but to get specific for the VOTEC physics class, accelerations are you as a future mechanic or someone who works on vehicles, you need to know about accelerations in terms of vehicles because that's kind of important. All right, so vehicles change speed, and they speed up and they slow down, and all of that it puts stress on a vehicle in various ways and causes it to wear out. Okay, so it's something that you guys in particular need to know about with respect to vehicles. All right, so let me talk about accelerations. And the first thing I want to say is, well, here's what I'm going to cover. I'm going to cover what the meaning of acceleration is. I'm going to cover 3 ways to accelerate, and I'm going to cover how to do a basic calculation, like how to calculate how much something is accelerating. All right, and then I also wanted to end with just a little bit of talk on the acceleration due to gravity, because in physics it's kind of an important acceleration. And so that's where we're going to go. All right, so what's the meaning of accelerate? When we say something's accelerating, the first thing I want to say is it's one of those words that people screw up in the English language all the time. Accelerating does not mean fast. Most people screw that up, and they use they use the word acceleration to mean that you're going fast. Like they see, some fast-moving vehicle, like an aircraft or a fast-moving car, and they're like, wow, that's really accelerating. No, because you can be accelerating and still not be moving all that fast, all right? It depends on your rate of acceleration, all right? Acceleration is not speed, okay? Acceleration, what it is, it's a change in speed. Okay, and it's a measurement of how fast or slow you're changing speed. So let me just go with this. This is a metal ball that I have from our classroom that I brought home, and I want you to just think about this for a second. So right now the ball's not moving. I'm holding it above my hand, and if I take it and I drop it, and if you think about what happened to it, all right, it started from 0, and then it fell, and then it hit my hand. And so it starts from 0, then it went to some speed. And actually, if you think about it, now in class, I tend to go through this a bit more, but I would pick someone in the class and say hey, between 0 and whatever speed it hit my hand with, what happened to its speed? Most people answer correctly, well, it sped up. And that's true. We know that gravity causes you, when you fall, to not just stay at the same speed, but to speed up. That is, until you reach something called a terminal velocity, which is a different lesson. But until you reach your terminal velocity where you stop, you're speeding up. That's what gravity does. That's why, and it does it pretty fast too. Okay, that's why when you jump from any significant height, you're going to get hurt because you're going to hit the ground at a fairly significant speed for your body. All right, and that's not a good thing. So we know that that gravity causes you to speed up, and let's high school it up a little bit because you guys, in being in high school, can think a little bit deeper. I want you to think of, okay, so between 0 and whatever speed it hit my hand at, how many speeds did it go through? And so most people will kind of ponder that for a second. They'll say I don't know, 3, and they're thinking 1 mile an hour, 2 mile an hour, 3 miles an hour, something like that. And that's not the case, because let's say you go from 1 mile an hour, or from 0 to 3 miles an hour. Let's say it hit my hand at 3 miles an hour. Which is reasonable, actually. It didn't just go through 3 speeds, 0, then hit 1, then hit 2, then hit 3. Because you can get, if you think about it, you can get a little more specific than that, because, well, what about 1.1 mile per hour? Isn't that a speed? Yes, it is. What about 1.2? That's a speed too. So, all right, so it's more than just 3 speeds. Well, let's get even more. Let's go down the rabbit hole a little bit further. What about 0.11 mile an hour? Did it go through that speed? Yeah. What about 1.111 and so on? All right, and you see where I'm going with that. And the reality is, the short story is, how many speeds did it go through from here till it hit my hand? It went through an infinite amount of speeds. And I want you to ponder that for a second, because most people aren't used to thinking about the concept of infinity. But infinity is a very real thing. How many speeds did it go through? It went through an infinite amount. Okay, because you can keep going, down the decimal places an infinite amount of times. And the way I want you to think about it, see, acceleration is a change in speed. You're not at any one speed for any length of time while you're accelerating. And if you're talking about vehicles, you do this all the time in vehicles. You're at a red light, you're at 0, the light turns green, and you go up to, 40 miles an hour or so down Tioga or whatever. How many speeds did you pass through between 0 and 40 miles an hour? An infinite amount. Okay, so that's the concept there. So you go through an infinite amount of speeds when you accelerate. You're not, and you're at any one speed for an infinitely small amount of time, and that's the deep. If you understand what I'm saying, now you're starting to get an education, at least in this aspect of human knowledge. Okay, because you know more and you're thinking deeper than most Americans think, for the most part. Okay, so when you accelerate, how many speeds you go through? An infinite amount. How long are you at any one speed? So as this is falling, how long it passes through 1 mile an hour? How long is it at 1 mile an hour for? An infinitely small amount of time, because 1 moment later, it's not at 1 mile an hour anymore. It's at 1 point, whatever miles per hour. It's sped up. Okay, that's a deep concept that most people don't grasp with respect to acceleration. I'm going to ask that you ponder that, okay, and know that, okay, because, well, you're in a high school and you're getting an education, and that's why you're here, all right? You're here to learn stuff like that. All right, so that's what an acceleration is. Now, that being the case, there are 3 ways to accelerate. A lot of people just think that accelerating is just speeding up. That's not the case. Because if you think about it, if you're changing speeds, there are different ways to do it. You can speed up, but you could also slow down. That's a change in speed. And that's what happens when you hit the brakes on a car. You're going 65 miles an hour. There's some guy in front of you going slower. You can't change that. You got to slow down. So you go from 65 miles an hour and you slow down to 45 because of the old lady in front of you or something like that. Whatever. But you changed your speed. There's a third way to do it, and let me erase this for a second, okay, to kind of illustrate this on the board. And actually, I'll get into that third way in a second. Let's just, at the very least, get some notes on the 3 ways to accelerate. So the first way is to speed up. All right, let's get technical, because you're here to learn language also. We call speeding up a positive acceleration. Okay, so we got that. The second way is to slow down. And, well, if speeding up is positive, guess what slowing down is? That's a negative acceleration, to use some technical language. And especially you guys in the VOTEC course, I want you to know some technical language, all right? Remember, working on vehicles is getting a little more complicated, all right? So start thinking of yourself less as an auto mechanic and more of a technician, a specialist, which means that you know the language that goes with your trade. So slowing down is a negative acceleration. And sometimes we will say it is a deceleration. These 2 terms mean the same thing. Okay, so whatever. The third way, because velocity is a vector. All right. Now memorize it's actually not just a change in speed; it's a change in velocity. Velocity is a vector, and a vector is a size and a direction. Okay. So that means that you could change the direction of a velocity. So if you turn, so the third way is actually by turning. When you're turning, you're accelerating. And we have a special name for that, and that is called, and let's see, you can still see it. Yes, you can. All right, still got board space. It's called a centripetal acceleration. All right, and the word, just so you know, you have some background, the word centripetal means center seeking in Latin. Okay. Why? Because that's an acceleration that you have by virtue of the fact that you're going in a curve, and any curve can be looked upon as if it's, even if it's not a full circle, can be looked at as if it's part of a circle, and every circle has a center, hence center seeking. Okay, so that's the deal with that. All right. Now I want to also point this out about the turning thing, and this will help hopefully make sense. You can, and please write this down if you're going to forget it, you can feel an acceleration. You feel when your body is changing speed. If you think of yourself in a car and you're at a red light and you're at 0 and then the light turns green and you speed up, you feel like you're getting pressed back into the seat. You feel that because your body, according to Newton's laws, does not want to speed up. Okay, it resists speeding up. It's your inertia resisting you speeding up, and that's what you feel. So you feel that speed up, and the more the speed up is, the more you feel it. All right, if it's a gentle thing, that's not so bad. But if you consider yourself being launched on like one of SpaceX's rockets, into space, where you have to go from 0. Escape velocity is something like 22,000 miles an hour, which is much faster than a bullet from a gun. Think of the acceleration that your body has to go through in order to get up to that speed. You would definitely feel that. All right. Slowing down, you feel also, because you're moving, and if someone steps on the brakes of a car, what do you feel? You feel yourself going forward, because your body, your inertia, is resisting the change in velocity. You don't want to slow down. Okay, so you feel that. You feel like you're being forced forward. And you also know when the car turns. When you're in a vehicle, and if someone has to turn really hard to the left or the right, you get slammed to the side. Why? Because your body wants to go in a straight line. Your inertia wants to carry you in a straight line. It doesn't want to turn. It resists it. So you feel when you're being forced to turn. So make sure you know that you can feel an acceleration. You can't feel really a constant speed. And the perfect example of that is just the fact that right now you think, well, I'm just standing here, or I'm sitting here and I'm not moving, but you are. Why? Because you're on a planet. And the Earth is moving at about 20 miles every second as it goes around the sun. Why don't you feel it? Because that's pretty fast. 20 miles a second from here to New York City in some 7 seconds. All right, that's pretty fast. Why don't you feel it? Because you're not accelerating. It's a completely smooth ride, the Earth is, and it's not speeding up or slowing down. In fact, let you in on a little secret in physics, and here's some Einstein for you. Not moving and moving at a constant speed, according to the universe, are the exact same thing. There's no physical difference between moving at a constant speed, however fast, and not moving at all. Okay? So ponder that for a bit. All right, now, so those are the 3 ways to accelerate. Let's talk about calculating an acceleration. So here we have it. And the equation for calculating acceleration is it's actually pretty common sense. All right, so A for acceleration is a change in velocity. Well, you know from math class, you don't have to write this down, right? Delta y or delta x. All right, one of your math teachers taught that to you, that the triangle means change. All right, rise over run, change in y over change in x. All right, so it would be change in velocity over change in time. Okay, and that's the basic equation. We're going to expand that a little bit. Okay, so what that means, we're going to use changes instead of y2 versus y, minus y1. We're going to use, obviously, well, one, we're not using y's, we're using v's, but instead of 2's and 1's, we're going to do little f for final velocity minus v with a little I for initial velocity or your starting speed. And instead of writing tf minus tl, we're just going to write t. Why? Because the starting time is usually 0 seconds, 0 hours. So anything minus 0 is just itself. So we're just going to leave it at t to keep it, a little bit simpler. Okay, so a good example. Let's say that, all right, we're starting at a speed of, let's see, 0 miles per hour. Actually, I'm going to use meters per second. Okay, and we're going to speed up to a speed of, let's see, 10 meters per second, and we're going to do that in a time of, let's see, 2 seconds. What's our acceleration? Pretty easy. Just kind of plug the numbers in. Vf is 10, all right, minus Vi is 0, divided by 2. All right, now the units are meters per second and seconds. All right, so this is just 10 meters per second divided by 2 seconds. All right, and with 10 divided by 2 is 5. Now the units, meters per seconds divided by seconds, again, we write as, let me write that 5 a little better, 5 meters per second squared is how we write it. That makes sense, those units, all right? And I want to explain why, all right? So let's say, if I could erase this, let's say that here's like a cliff and here's like, I don't know, like a bowling ball or something. And we're going to drop a bowling ball off a cliff because we just find that to be fun. And so the bowling ball is going to start at 0, just like when I dropped the little ball there. So we're going to hold it over there, then we're just going to let it go, let it drop. And it's going to accelerate, all right? And so actually the number for the acceleration due to gravity, A due to gravity, is 9.8 meters per second squared. What does that mean? Here's what it means. It means that 1 second later, right, at t is 1 second, 1 second after you drop it, the bowling ball will be passing through the speed 9.8 meters per second. It's not going to stay there. It's going to get faster. It's only there for an infinitely small amount of time. 2 seconds later, it's somewhere down here. All right, and this is a farther distance. Why? Because it's speeding up. It's constantly speeding up. So every second you cover more distance than the second before. All right, so here we are. T is 2 seconds. How fast is it going? Well, it's 9.8 from before, but it gained another 9.8 meters per second in that next second. It's speeding up at a rate of 9.8 meters per second. It's getting faster by 9.8 meters per second every second that it falls. Okay? So it would be traveling at 19.6 meters per second. 2 seconds after you drop it, it will be passing through the speed 19.6. 3 seconds, and I think we can still see that. Yes, we can. Okay? Sorry, the lights are and it's tough for me to see my Chromebook screen. It would be traveling at 9.8 there, plus 9.8. But in that third second, from 2 to 3 seconds, it would have gained another 9.8 meters per second. And what's that, something like 27.4 or something like that, but you would get another 9.8. I also want you to notice a pattern here. 1 second after the object falls, it's going 9.8.
which is the same as 1 times 9.8.
2 seconds after an object falls,
it's traveling at 9.8 plus 9, or 2 times 9.8.
3 seconds after an object falls,
It's going 9.8 plus 9.8 plus 9.8, or 3 times 9.8.
after 4 seconds of falling, if you're dropping it from a very high place, it would be going 4 times 9.8. And you could actually use this to calculate any speed in between. So let's say you wanted to know how fast an object was going after 2.5 seconds of falling.
What would you do? Well, it's in between here and here, but that's pretty easy to do according to this pattern. If you wanted to know at 2.5 seconds, what's the speed? It would be going 2.5, that's an 8, times 9.8. And that's how we would figure that out. Okay? And actually I kind of jumped ahead and I just kind of explained the acceleration due to gravity there. All right? Gravity, by the way, this acceleration, just a little bit of meaning to this, we would say that the acceleration 9.8 is 1g. Okay?
If you're in a vehicle, okay, like a racing vehicle or something like that, and you totally floor that thing, you might experience, you can actually kind of talk about acceleration in terms of G's. Okay, so let's say you're in a very fast vehicle and you're accelerating, like say you're in a rocket, or let's say you're in a dragster or something like that.
All right, you might experience 2 G's
of acceleration. All right, what would that mean? That means you're accelerating at twice this rate right there. Okay, so you're getting faster at 19.6 instead of 9.8, and that would be a 2g acceleration. A human body, all right, like fighter pilots and stuff like that, because you can also feel g's as you're curving, right? Because that's an acceleration too. Can undergo, I want to say something like 4 or 5 g's of acceleration. After that, people start to black out, okay, because the blood literally drains out of their brain as that's happening. What that really means and what it feels like is under a 1g acceleration, which you are all in right now, you feel normal. Under 2g's acceleration, you feel twice your weight. So if you weigh 100 pounds, and you're in a vehicle that's pushing you at a 2g acceleration, you feel like you weigh 200 pounds. And for all intents and purposes, you really do. You would have a tough time lifting up your hand. Under a 5g acceleration, if you weigh 100 pounds, you would feel like you weigh 500 pounds. There'd be no physical difference, all right, between weighing 500 pounds or weighing 100 pounds, but accelerating at 5g's. Okay, and that's the truth there. Okay, so you have that. Let me do another calculation, and that'll be the end of this video. Well, let's do a slowing down. So let's say, for example, let's go to our equation. A is Vf minus Vi divided by T. Okay, so let's say that you're slowing down now. So let's say that you have an initial speed, and let's not make it 0. Let's make it, well, it can't be 0 if you're already moving, but let's make it 20 meters per second, okay, which is, that's something like, 75 miles an hour or something like that. And we're going to hit the brakes and we're going to slow down to, let's say, 5 meters per second. So our final velocity is going to be 5 meters per second. Okay, and we're going to do this in a time of 3 seconds. So we're going to hit the brakes. We're going to go from 20 to 5 in 3 seconds. So what's our acceleration? A is equal to, follow the pattern there, Vf is 5 minus Vi is 20. Okay, and we're going to divide that by 3 seconds. And 5 minus 20 is negative 15 meters per second divided by 3
seconds. 15 divided by 3 is negative 15, divided by 3 is negative 5. So negative 5. And again, meters, when you have the 2 seconds there, it's meters per second squared. And so remember how we call a decelerator, slowing down, a negative acceleration? That's why. Because when you actually do it in the calculation, it comes out as negative. Okay, and that's the reason for that. Okay? All right, so that's pretty much a decent background on acceleration and how it's different from speed and so on and so forth. And it's all stuff I want you to know, so make sure you got the notes on that and make sure you're paying attention. And there you go. All right, so namaste, and go this out and enjoy your apocalypse.